Hello, my name is Janusz and I will talk about benchmark Faster LIO to HDMapping component. So we will create a movie, how this LiDAR odometry algorithm will perform on the dataset. So let's click this link. So we have our repository and we have hint that change branch to bunker DVI dataset. So it will be much faster because we created branches for each separate experiment. Due to the fact that we have already data, so we don't have to perform step 1, so let's focus on step 2. We start from step 2. So it is very easy that you simply copy and paste all instructions. This benchmark is prepared for people that not necessarily are familiar with Linux. I hope you can manage to have one. So we now cloning our repository. Now we are going there. Then we change the branch into our bunker branch, and we build Docker finally. So our step 2 is already prepared. We go to step 3. So in this step we run our Docker, so we run our experiment. So we change some parameters of the files, we go there, and finally we run our experiment that will show you how to make map using Faster LIO algorithm. It is in ROS 1, it is end of life unfortunately, so maybe you should consider to migrate to ROS 2. Hopefully authors of this algorithm will do that for you, but we don't know yet if they have this plan. Okay, so on the right side we have working algorithm, and on the left side I will show you dataset to give you some overview. So this is our dataset. It is collected with this device. So we have LiDARs, cameras, stereo cameras, time-of-flight cameras, and this dataset is created by our colleagues from Royal Military Academy in Belgium and Ghent University. So you can, you should honestly cite our colleagues, but I have to convince them to change this information. I can see that it's not changed. The paper is already published, so they should change it. So shortly speaking, we have nicely working algorithm. The idea behind this is that we will make a benchmark of all algorithms. Give me a second. HDMapping. Of all algorithms we have. So this is our website, and the idea is that we will collect all algorithms that can process all available affordable LiDAR systems. This is our scientific goal, that we will find the best mobile mapping system, either in literature, either we design our own, either we find based on our experiments. So what we have so far, we have some algorithms already, like HDMapping LiDAR inertial odometry, we have postgraph SLAM, and we have georeferencing. And our tool can give you opportunity that you can create city level maps, and this is example of that. And I am very happy to tell you that it is possible. It is still painful, it is quite difficult to do that, but it is possible. So what we are working now on is that we are trying to make this software much easier for people. We are working heavily on videos and so on. We don't have much people in this project, so please be patient, but every week we are trying to update this project with things that they are necessary to improve the end user experience. So what we have so far, we have a benchmark of, I will make it bigger, we have benchmark of 20 algorithms, and we have rapidly growing to-do list. So we are trying to find all algorithms in literature from the best conferences, and we are working how to make it working together on certain data sets. So what you can see here, we are working now on Faster LIO, and our approach is that we build a Docker for each algorithm. So we have a separate environment for the algorithm. And then once you run our Docker with prepared data, then we provide import-export tools that you can easily export result from this algorithm into point cloud and trajectory. And once you have trajectory, you can perform some analysis of the trajectory. But also, what is more important for us, we provide point cloud as a map. In that sense, you can compare the quality of the final map, because it's not only trajectory important. Trajectory is important looking from localization point of view. So imagine that you have a robot and you would like to localize, the trajectory is essential for you. But imagine that you would like to make a map, that will be useful for certain purposes. Therefore, your map should be on high quality. And it's not so common that algorithms, like the inertial odometry algorithms, they care about the quality of the map. It's not so obvious these times, and I'm struggling to tell you that it's difficult to justify what is essential for the algorithm, what is the novelty of this. So this benchmark is designed especially for that purpose, that you can compare qualitatively and quantitatively and qualitatively trajectory and a map. Okay, so shortly speaking, we are approaching end of the survey. So we back to our data set, and in the second I will show you how to import and export data from these results. So what we expect that in our data set new folder will appear. You can see already 6 folders from previous movies that I created, and now we are waiting for the Faster LIO folder. So let's hope it works. Okay, it works. Faster LIO appeared. You can see here that everything is done. So let's enter our new folder, and you can see the session file that is important for us, that it is organizing poses, LiDARs and trajectories. So we open our multi-view TLS registration step 2. We open the session. We open session file, and we have our trajectory and points. Once you decrease here decimation, down sampling, sorry, then you have entire map, and you can use it in many possible ways. So let's export file, save all marked scan as a global scan. So we have this Faster LIO, so we have pc global.las, and you can export trajectory, save or max trajectory as XYZ and quaternion. So we are Faster LIO. Where I am? Faster LIO trajectory global.csv. Okay, so we have data exported here. We have point cloud and we have trajectory. So let's open Cloud Compare. I hope you are familiar with this tool. So you can simply load your point cloud, and you can easily load your trajectory. You have XYZ coordinates. Everything is okay. And what you have, you can play with the point cloud for your own purposes. So we have trajectory, and we have our map. Thank you for watching this video. It was Faster LIO algorithm, so it was this one, Faster LIO algorithm, and see you next movie. See you soon.